Now that we have successfully pre-processed our data, the data set now looks something like this. So we have all the input features in our x variable and the output feature PCE in the y variable. Now we have to take some portion of our x and y for training the model and keep the rest for testing purposes. So in general, we take 80% of the data for training. You can choose 70% or 90% based on your preference. This is chosen randomly from the entire dataset, and the remaining 20% are kept away for testing. So among the 80% of the training dataset, you have to further split them and name the X portion of the 80% training as X train, and the Y portion of the 80% training set as Y train. Similarly, the X portion of the 20% dataset that will be kept for testing as X test, and the remaining 20% of the test set as Y test. Now, we will after training the model with these X train and Y train, the model will try to relate the input features with the output features and try to find a pattern between them. And then we will give the model the X test, and the model will and we will hide that Y test from the model. We will not reveal the Y test to the model, and the model will give its prediction about the PCE, which we will denote as Y pred. And lastly, we will see how accurate the model was as predicted our Y test. And the more Y pred is closer to the Y test, the more accurate our model will be. So that now let's implement this into our code. Splitting. We basically have to do this. As you can see, I've kept the test size to 20%. That's why I've written here 0.2, and the remaining 80% are for the training of the model. Now all we have to do is apply the regression model. So first I'm gonna apply the XGBoost regression. So to apply XGBoost regression, we have to implement this code. So now let's run our code cells. So the model has been applied to the X train and Y train. So in short, the model has been trained. Now we have to predict the Y test here. To predict the Y test results with the model's prediction, we have to set a variable called Y pred, and the X test, the 20% of our data for the input feature to predict the model, the predict with the model. And we want to sort of compare the Y pred and Y test side by side with two columns. So that's why we leave this sort of code. It's optional if not necessary. So as you can see, in the first column, this is the model's prediction of our PCE, and in the second column, this is the actual values of the Y test, and this is the Y pred in the first column. So for the first row, you can see that it has predicted the PCE correctly, and some of them are really close. So almost all of them are really close. So our model was very accurate. So if we want to check how accurate our model was at predicting this data, we can do something called an evaluation process called the R square value. So I will do that in the next cell. So this function will output a score that less than 1, and it can go up to 1. The closer this value will be to 1, the more accurate our model will be. So with this code, we can compare two different models on the same dataset to check which model was more perfect at predicting the efficiency. So let's run it. So as you can see, it's almost 1. So the model is extremely efficient for our data set. This is probably because our data came from a simulation software, so there were no uh, outside random events happening. So the data was well behaved, so the model was able to predict it. So the model was able to predict it easily. Now all that's left is to plot some figures, right? So let's first plot the scatter plot. So these are some formatting related code. So let's go ahead and run this cell. So as you can see, we have plotted the test set with our prediction. So this diagonal line, the dashed line is the prediction line, and we have only included the test set here. But in the paper, you can see that they have included both the training set and the test set. Since the training set is just for the training the model, so I don't think it's necessary to include in our scatter plot. So the more closer the blue dots are to the diagonal prediction line, the more accurate our model is. Since our model is 0.9999% accurate, we can not distinguish the inaccuracies in with just our eyes. Now the shape curves. So these are the code for the shape curve, and if you see here, we have inserted back the feature names, the four columns for our input features, the absorber thickness, defect, and donor density, to be able to show them in our plots. Otherwise, they would have just, let me just cut it first and demonstrate how it would look. So this is our shape plot. If we don't denote the feature names explicitly, this will just look like this. So that's why we have to explicitly name those features as an array of strings in the parameter feature names. If we run it again, so there we go, the feature names are back, and we can see that our shape curve is slightly different from the curve of the paper. It's probably because I had a different device configuration, slightly different device configuration. I did not word by word, value by value insert the data from the paper, so it resulted a similar pattern but not identical. So this is the XGBoost regression model, and if I want to apply the random forest regression model on our code, we just have to change uh, a few lines, 2 or 3 lines, and the random forest regression will be applied. So we'll go into our applying the regression model. So all we have to do is change these lines in order to apply the random forest regression model. We now have to import the random forest regressor and fit the regressor with the X train and Y train of our dataset, and we can just run the cells from here again. So the prediction is complete. Now for the XGBoost, it was 0.999996. Let's see how the random forest regression performs in our dataset. So you can see it also has a high R2 score, but it slightly less accurately predicted our model. So there are 4 9s as you can see, but it doesn't make any difference, right? So for our scatter plot, this is our scatter plot, and for our shape curve, this is our shape curve. So we have successfully created the random forest and XGBoost regression model for our data. So that's it for this video. We will try to implement the neural network model for this dataset in future video.